previous session of fundamentals of MATLAB, we were looking at the structure, and we completed structures with the various operations on structures, right? So today's session, we will begin with the concept called as a cell array. So we know that the cell array is a data type with the indexed data containers, and we call those containers as cells. Okay, so this is a data type with indexed data containers, right? We call them as the cells. So the basic characteristic of each cell is that it can contain any type of data set, right? So how to create? So to create a cell array, we are going to use flower brackets as an operator. Okay, so this operator we can use to create the cell array. All right, now we'll go to MATLAB window, and then let us see how do we do that. Okay, so let's create a cell first. Say I'm going to give a name as my cell is equal to. So as we already have defined, we are supposed to use the flower brackets, and the entry of each cell. See, what you are creating here is not a single location. You are creating a cell, and by definition, the cells can contain any data type. So I'm going to show that now. So let me put some numbers in the beginning. 1, 2, 3. See, these are the 3 cells have been created with the integer data type in that. So then I'll go to, maybe I'll create a next. I'll go to a, I'll make it, add a new cell, new row of cells to this. So already I have added 3 cells in single row. So 3 columns have been created. Let me go to the next row, and there I'm going to enter, say, text, right? This is the next cell, and then let us create a multi-dimensional array. So this is a rand of, right? So I'm going to create 5 rows, 2 columns, and say 10 such pages out of it, right? So that's the next entry, and let me go further. I can create a cell inside a cell. So I'll create one more. I'll open a bracket. So this is a 11 semicolon 22 33. See, this is 3 rows, 1 column, that kind of a cell, and I'll close this. So just see, when I click this, we could create a 2 cross 3 cell basically. All right. Okay. Now, uh, so you see the 2 cross 3 cells have been created, and each cell contains a variety of data, right? You can actually add any type of data to this, right? So that's about the creation of the cell. So once the cells have been created, right, now we'll see what are the various options we have, what are the various operations we can perform on the cell structures. Okay, right. Now, let's see another type of a cell creation, you can actually create cell of any size, a of any size, like multi-dimensional cells are also possible. And when you are not assigning anything, right, you can simply create the empty cells as well, right? So we'll see that option now. So in order to create the empty cells, right, again, this could be any n dimensional, right? So use a function, right? That function is called cell, right? Inside that, I just have to mention what is the dimension, how many rows, how many columns, and how many such pages are required. So in order to create a n dimensional empty cell, this is the procedure. So if at all I want to do the same thing in MATLAB, I'll create my empty cells is equal to, I'll call a function cell, and just give the size, right? 2 rows, 3 columns, and 5 pages, right? So simply, just now you can see that the 5 pages have been created. Everything is empty, right? There is nothing. So you can see it's a 0 into 0 double, right? Depending upon the content of the cell, right? We are going to the size of that cell array is going to change. For example, let us check with whos. You can see that we have two variables over there, my cell and my empty cell, and we can see that the my cell takes 1800 bytes, whereas the empty cell structure of 2 cross 3 cross 5 uh, takes only 240 bytes. It depends on the contents, basically. Okay, then now let us see how to access the data in the cell array. Right. So in order to access the cell array, definitely we are going to use the indexing techniques, right? But since it is a cell array, the indexing method is slightly different compared to other types of data. Right? So in order to access the cell contents, so here we are going to access the data in access the data from the cell array. Right. So first, let us try to write a particular. uh, Okay, let's first create the cell structure, and in order to read any data, uh, we are going to use, right, the indexing in terms of the parenthesis. Okay, THESES, parenthesis, just like this, for indexing. So by simple parenthesis, we can access the data contents of the cell array. So let's create a cell now. I think we already have created, so that is, I think it's in the name of my cell. It's already there. So what I'm going to do now is equal to, so I'll try to extract, that is my cell 1 comma 2, first row second column, right? I can also use, right, the complete first row, right? The maybe third row, right? All the third column, sorry, right? It's like this. And I can also access multiple elements like 1 to 2, row number 1 and 2, and column number 2 and 3, right? So 2 rows, second and the third column, right? Again, that is possible using this. So you can access the uh, cell array by using simple indexing, right? Now, how to update, right? Update can be done by simply using assignment, right? Let me say I want to uh, add a new column. Let us try to do that. Okay, so maybe previously we had say 2 cross 3. The size of the cell array was 2 rows, 3 columns. And let me say I want to update something from this. Okay, so I can do that simply by doing the assignment. So how to do the assignment? It is straightforward. So my cell, I will say that I want to update this. So what is the original size? If you see the original size, 2 rows, 3 columns, correct? I want to add something to this. So I will say third row, okay, row number 3, comma, first to third, right? Third row, 1 to 3 is equal to, right? Let's add something to this. So it has to be a flower bracket. Then maybe enter a number 5. Maybe I'll just enter say 5. Then I want to add new text, right? Something else comes up, and then add ones of 1 comma 5. Fine. So I'm adding this. Now let's check. So you see it actually got extended. The third new row has been added with so many columns, right? Also, you can actually update something, right? Let me say I just want to remove this 2 and I want to update this with the letters TWO, right? We can still do that. So the my cells, I think that is my cell of, so this is first row, second column, right? Update simply that. So update that. This is equal to this, then enter whatever we want to update, then close this. So you see it's now changed. You see this is 2. Okay, now let us say uh, we have one option here, that is uh, we can try to extract the numbers from this, right? Wherever you have a numbers, right, we can try to extract that. In the sense, if the cells of our array contain numerical data, then actually we can convert the cells into the numerical array, right? Directly this conversion is possible, but there is a condition that the cell array must contain numerical data in between. So for example, 1, I can see this is 1, 3 and 5, they are numerical, right, in this particular cell. So I can actually convert only them into the numerical array, provided I have them in a in my what you call array format, if at all I have them, right? So for the time being, I'll do a modification here, because I don't want this to be 2. I simply enter this as a 2. Now this means I'm getting back my original one. So now I can actually write something like this. So I'll try to extract them. Numeric cell is equal to, this is my cell, the complete first row, let me say, okay, first row, all columns, right? You can see that the numeric cells contain only the numeric values as of now, because the first row I observe that it contains only numeric data. So I try to extract them, put it into a numeric cells. Now the numeric cells a variable contains a 1 into 3 cell array. Okay, now this cell array can be directly converted into the normal array containing numeric data. So how to convert that? We have to use a function called cell to mat. Okay, so let me just make a note of that first. Right. So this is if our intention is to convert the numeric cell array into the normal array, right? We have to use a particular function, and that function is called as cell to mat. Okay, basically you are trying to convert the cells into matrix. Okay, that's why the function name is given as cell to mat. It is easy to remember as well. Okay, so let us try to see the conversion. So I will use a, maybe this is my matrix is equal to cell to mat. Name the variable. I think the variable is just now we have used numeric cells. Right, so now you see the result. This my mat is actually a normal array. Okay, so we can check whose. So let's check that. We earlier had numeric cells, so you can see that this is a cell, but the my mat variable is also 1 into 3, and it is of size double, and it is an array of size 1 into 3. So you can see, compare these two and we understand that. So the cells have been converted into the normal array. Okay, this is a very useful function in MATLAB. Most of the times when we save data in the cell format, and then we want to process the data, we will convert them into cells, and we can actually proceed further. All right, so then let's move further. Now, so the basic structures, basic data types are completed in the MATLAB fundamental session. Now what we are going to do, we are going to look at the next topic that includes operators. So first let's look at the basic arithmetic operators. Right, so anyway, since we are aware of the uh, basic operations that we can perform using all the arithmetic operators, we can go a bit fast over here. Okay, so let me just paste a diagram over here. Just we are going to use this as the reference. All right, so what are the operations we can perform in general using the arithmetic operators in MATLAB, like any other programming language? You can see the arithmetic array operators, it can operate on just a number or the arrays, right? So you can see addition, unary addition is possible, subtraction, unary subtraction, element wise multiplication is a dot star, right? Then you can see here the dot power, element wise raising them to a power, then element wise division, that's called as a right array division, left array division, and the array transpose. Everything is possible under the concept of arithmetic array operations. Okay, in addition to the arithmetic array operations, we can even go ahead with the matrix operations, right? Whenever you are going to perform the matrix multiplication, matrix addition, right? Not a element by element, like the normal matrix calculation, that is also supported in MATLAB. So that are as follows. So just see now, I'm going to paste the contents related to the matrix operations. Okay, so the matrix operations are as follows. So you can perform the matrix multiplication by using a normal star. Then you have a left division and right division possible. Okay, and you can raise a power of a matrix, right, and take a complex conjugate transpose. So these operations are we are very familiar with the normal matrix operations. If you want to perform, you can use them between any of the matrix, any of the two matrices. Then moving ahead to the next set of operators, we are going to look at what is called as the relational operators. So when we say relational operators, basically we are talking about the following, right? You can actually check whether something, whether the right side of an equation is equal to the left hand side of the equation. So that is, you are trying to determine equality, right? Then the next operator is greater than or equal to, greater than, less than equal to, less than, not equal to, that is inequality. And you see that you can write a function to check that that is equal, right? And is equal not, that is a complicated, right? Or you can even check for NEN, right? Fine. Then let's move on to the next set of operations. uh, yeah, okay, let's quickly go through some of the examples of what we can consider for these operators, right? We'll quickly check some of the examples. So let me clear and perform a CLC. And now let's say we create an array first, right? So A is equal to, I'll create a 2 cross 3 array. Say 1, 2, sorry, this is 1, 2, 3, say 5, 7, 9. This is the first array. Okay, then I create another array, say B is equal to maybe 2, 4, 6, 5, 9. Okay, I created two arrays. Now I can simply say that A less than B. See, this is how I use the operator. It says that wherever the condition is satisfied, whichever positions, you are getting answer 1 over there. It's a logical array, and you can see the answer comes 0 wherever this condition is not met. Okay, I can also check something like A greater than say 5, right? You can see whichever number elements of that array, right, is going to satisfy this condition gets answer 1, otherwise 0, right? So you see, this is the usage of the operators which we have discussed. All right. Again, if we compare something like a 1 by n to a m by n vector, MATLAB expands the vector into a m into n matrix before it performs the computation. All right. So similarly, let's go for the logical example. So in this case, okay, I have the numbers, and okay, let's check the condition A. Say A less than 4. I'm going to perform an AND operator. You see, this is logical, right? And I will perform, say, B greater than 3. So when both conditions are met, the answer is 1. Otherwise, it is 0. You see, you are actually performing the AND operation, right? So the logical AND, logical OR, logical NOT, X or X or etc. are also supported. So what are the options we have? So these are the options we have. Okay, I'll just show you the logical operations now. So all the logical operations that are supported in MATLAB are like this. So we have the logical operators like this. So logical operations are including and or not, the XOR, right? And in addition to that, we have some of the functions like all, any, false, find, is logical, logical, true, right? So like that, we have the various functions and the operators supported related to the logical operations, right? So you just remember these names, and whichever you want to look at in detail, you can use the help, right? You can quickly type help space, say any, right? It gives you the complete details of that, right? Whenever. So basically we know all of them, but how exactly it's going to be used in MATLAB, you can check, right? Okay, anyway, we have discussed the use of the MATLAB help, how to access the help and how to go ahead. Already we have seen it, right? Now, let us look at the concept of logical indexing. All right. So, logical indexing is actually one of the very important concept, right? Use some logic to access the uh, matrices. That's our next concept. That is logical. Again, I'm trying to give an example over here, right? We are not going to discuss in very detail because when it is needed, we can definitely use these concepts. All right. So let's go back to the MATLAB window. And here, let me create, first let me clear, then fine. I'll create what is called as RANDI. RAND creates the random, what you call random numbers between 0 to 1, right? But when you say rand I, it creates integers, random integers. Say I'll say up to number 15, and this is the I max, maximum integer. And what is the size? If you want to go for a size of 5 cross 5, you can simply enter 5. So you see it creates like this. Now let me say I'll use a I create a logic array b equals to the elements of I have to find where I am having a values less than 9. Okay, okay, sorry, I think I didn't create the a itself. So let me create a is equal to this. So now you see a is less. Now I can actually enter b is equal to a less than 9. Wherever I find a less than 9, I'm trying to uh, get the answer in b, which is a logical array, says ones and 0. Wherever the condition is met, it is 1, otherwise it is 0. Okay, now what I'm trying to do here is in this a, right, I want to find, right, what are the positions. Okay, so extract the values that meet the condition, right? So in order to extract those values which meet the condition, I just have to write a of b. See, b is a logical array, right? So you are using logic to access the contents of a. B is a logical array, you can use that. You see the values are like this: 7 3 4 3. I check that whether value is less than 9, correct? So all these values are lesser than 9. You can see 7 3 2 7 4 1 and so on, like that, right? Every value that is present over here. Now if you want to access their position, like there are how many elements, right? I created a 5, so 5 into 5, 25 elements are there. You can actually index them in a linear way, starting from 1 2 3 4 5 6 7 8 9 10 up to 25. So now we actually, you can find where they are located in that particular matrix. So to do that, I am supposed to use, right, maybe index index is equal to, simply use a function called find. Okay, find a less than 9. Just enter. You see, now you get the indices, right? Index number 1 3 4 5, then 6 10 and so on. So the size of both of them are going to same. The a of b has, right, 17 values, and even the index has 17. I can see here in the workspace. So that is what is called as the logical indexing when it comes to the MATLAB, right? But definitely we can go ahead and apply multiple conditions as well. Okay, so how to apply the multiple conditions to uh, access these matrices using some logic, right? We are going to see that now. So let's use the same matrices. Okay, I'll use the clear screen first, and then I'll write A because A capital A, sorry. Yeah, so in this I can actually perform A of, right, A less than 9. Can also perform a AND operation with the values of A greater than 2. Okay, less than 9 and greater than 2. If you have something, yes, this is the answer. Okay, so many elements are there, right? And right, find the elements in A that are less than 9 and even numbered, right? So the what is the logic to go for even numbered? Even numbered means mod operator, correct? So I can actually check them by simply using, again, this is a something like an example. So A of A less than 9, it should be less than 9 and it should be even numbered, right? So if I write something like mod of say A comma 2, this is actually going to generate the odd number. So I want even number, so I'm going to use a not in the beginning. Okay, the end, close this. Now you see you are going to get all the even numbers. Okay, so this is the logic. So anyway, this is just an example. In programming you can use many other sorts of logics as well to find even or odd numbers. All right, now uh, let's say I will use another example over here. Let me say in this A, right, I want to replace all the numbers that have a value greater than 9 by 9, right? So what's the logic? A of A greater than say 9. This gives you the where this gives 1. This gives a true value whenever this condition is met. If I assign say something like 9 to this, in the sense all the values will be converted to 9. You see, wherever you had a number more than 9, right? So all are replaced with 9 now. All right, now again I'll use another logic that I want to uh, replace all the values which are not equal to 10 in this particular matrix. Not all the values equal to 9. I want to replace them as not a number, right? Is it possible? Yes, definitely. So this is A of A that is not equal to 9, right? Equal to, I know I can use a NaN by default in MATLAB. It actually identifies NaN. You see, wherever I don't see 9 over there, it getting replaced as NaN. Right. Like this, you can actually use a lot of operations using the logical indexing as well, right? Then I can actually replace all the NaN values in A with the zeros. Okay. Then I can do this. So if something like A, this is again another example, I can use is NaN as a function, because we know that not a number can be checked using a function called is NaN. All right, so we are going to use that over here. Right, so is NaN of that matrix A assign 0. So you see all the NaNs have been replaced by 0. Then you can actually go for a complement. Okay, so the not of A is also possible, right? So let me create B which is equal to not of A. So you see, it's a logical number. Wherever you had zeros getting converted into ones, and any number more than one, if you have, it's considered as a true and will be converted into a logical array. Okay, so that is what uh, the operations using the logical indexing. All right. Now, how to convert the logical arrays into a single value. Okay, so let us try to uh, check that. All right, so let me create once again, go for a new array. Let us see. So A is equal to, this is A and D, random integers up to 25, size 5. Okay, I got this. Now I will say A is equal to, uh, I'll try to find the even numbers over there. Okay, not of uh, mod A, say 2. All right, so you get a logical array because I am checking, right, the not of mod of A, 2. All right, so you found that which of the elements of A are even, right? So wherever you have 1, it means yes, they are even number. Now I will check that any elements of A are even now, right? How do you check that? In the sense, if any of the element in this matrix is 1, you can say that there are even elements present in the array. So how to check that? You simply go for any. Any means any one number of that A, right? A, say all. You see, the answer is 1, logical 1, saying that yes, there are ones in this matrix. It's a logical matrix. A was a logical matrix, and when you checked for any, right, it said 1. Right, now you can check whether all are ones or not. All are even number. Can you check? How do you do that? You can simply go for a function called all. Okay, all. So I'm going to use okay, if I want to check all the elements are odd, see, the matrix represents even. You can still check it whether it is all odd, right? So just use a not of A of all the elements. Say it's a 0. It says that all the elements of A are not 0. Correct? If it is 0, it was odd. But since I performed a not of A, zeros became 1, 1 became 0. So I'm checking whether all the elements are 1 actually, right? And the answer says it is no. So you see, you converted the complete array into a singular value by using these functions. After the logical indexing, let's move on to the uh, loops and the conditions in MATLAB. So let's look at the various loops. And the conditional statements. So we have conditional statements as well as rules, as well as the loops. And when we have loops, right, we also need some conditions to break the loops and come out under certain conditions. So all are listed here. We are very familiar with them. So let's go through them very quickly, right? The execution statements based on some condition is true in the sense you can use if, and else, right? Then you want to execute a group of statements based on some condition, then that is switch, case, otherwise, right? You want to repeat a loop for specified number of times and you know the number, then you go for the for loop. Correct? Then while loop, when you don't know how many times you are supposed to repeat, but you know the condition, right? That's a while loop. Then you have a try catch, execute statements and catch the results, right? If there are some errors, right? So that's a try catch. Then you have a break if you want to uh, uh, as the name suggests, you can break the loops such as the while and for loops under some condition. That's why you use a break for that. Then return, you called a function, you want to come back to the function, you use a return, right? Continue is to skip the particular iteration of a loop and go to the next iteration. That's a continue. Pause means temporarily you can make the MATLAB to stop execution. Then there is also what is called as a parallel for loop, right? And you also have what is called as an end, right, to terminate a specific block of code or to indicate the last array index. We use this as a last array index, and can also be used as an identifier keyword to terminate a block of the code. All right, so let us try how to use some of the basic conditions. We'll write some codes, okay, just to make sure that you understand the whole process. All right, so let's go for let's do this in MATLAB. Let's write a file and let's save it as a M file and then do this. Okay, so this is for if condition, right? I want to check the if condition. So what I do, I create a variable a, and it is equal to a rand integer of up to within 100, and I want only one number to be created, and I want that to be assigned to a. Okay, then now I'll check if it is even or not, right? How do you do that? You are supposed to use a if condition, right? Now you see this is the format in which you write the if. So if you don't have to write a bracket in if you have you write the conditions over here, no need to write the brackets in MATLAB. It does not it will not it's not going to expect a bracket here. Simply you can write a condition, that is rem is a function to find the remainder, right? A when divided by 2, this equal to 0. If this is a condition, right, you are going to display, right, maybe I'll simply display a is even. All right, then I'll simply type end. So you see if has to be ended here. So instead of opening a bracket and closing a bracket like we do in C, C++, Java, etc., so you can use a end to specify end of that code of the block, right? So let me save this. My if code, right? Now I'll run this. Just see here. It will generate a number. So the random number generated is not even. That's why it has not been displayed. So let me run once again. So A is even. You can see that A generated is 30. So where only we have written a code, the logic is such a way that you generate a random number. If it is even, you display A is even. Otherwise, you don't do anything, right? Actually, you can even do the another part, that is else, right? Then come down and say disp, right? A is odd. Okay, now save it. Simply run. Now either of them will come. So the A generated is 75. You can see over here. Sorry, and a is displayed as odd. So you see the if else condition. So this is how you are supposed to write a if else condition in MATLAB. Okay, then let's go to another code where I'm going to show you the if else if format. Okay, in this case I will show you how to read the user data, right? So I'll write my number is equal to, I'm going to ask the user to enter. So whenever you are going to ask the user to enter, you have to use a input command, right? If you say input of, it expects user to enter something from the command window. So I'll show you that how. So you will simply say that what has to be displayed over there in a single quote. So you will ask the user to enter a number. All right, give a this thing, give a space, and maybe. So actually, when you run this, it's going to directly ask enter a number, right? And that entered number will be directly assigned to my number. Okay, so now I'll use the if condition. If, what's my first condition? That my number is less than 0. If that condition is met, you will say that you are going to right, negative. Okay, now I'll go for another condition I want to check, that is else if, right? So to say there is no space between, so I am going to disp else if. Okay, sorry, I need a conditions to be mentioned, sorry. If else if uh, my number is greater than 0, right? Less than 0 negative, greater than 0 I'll display uh, positive. If both of them are not satisfied, then else, right, you simply disp 0. So if, else if, and else can be used in MATLAB in this particular format. At the end of this if conditions, I have to use end to detect that end is over. So the if condition is over. Save. So I'll write this is my if else if. Okay, I'll run this by pressing F5. Now you can see that enter a number is being asked, right? It's being asked over here. So that means I'll enter a number like say 12. So you see, it's positive. Enter that, run that once again, and you can see that the number entered is minus 50, so it's negative. Okay, similarly, I can run this once again, and I can say 0. So you see, 0 has been displayed. All right, so both the programs, the previous program was simply the if condition. You see here, we used to create a randomly generated number, and number was generated. Instead of asking the user to enter the values, you used to generate the number by yourself, and you used to decide whether it is even or odd. So you see, it says a is odd, and what was the a created, you can see here. We are not displaying, so it's 19, right? So generate this once again. So you can see the new number generated is 69, and that is odd. So once again it creates 19, it 37, you see every time 63. It's randomly generating, so there is no logic behind this. And every time you press, right, now you see it's 78, and it says the number generated a is even. Okay, so that is the example of how to use the if and else if condition.